Okay, so I want essentially to start updating some videos now, going back across stuff. And one of the videos I wanted to update was the DNS security one, which actually is one of my most popular videos. So DNS security really is, just let me get rid of this. It really is the be all and end all. 98, I think it is, percent of attacks on the internet use DNS as a way of leverage. DNS is not only a fantastic way to get to websites without having to know the web address, but it's also it's a very easy way of obscuring something, especially when you start using different encoding for URLs and so on. So, wanted to update the other video because it was quite basic, and wanted to talk more about how to configure it to not be a pain, how to build it out so that you can put it in an enterprise environment and not have everybody screaming at you, and how you can quickly fix things should that start to happen. So a quick refresher on the components of the DNS security. So in objects, so there's two really. So there's URL filtering, where this is where sort of you go and you do your categories, and so for instance we have a home policy. So in the home policy, this was taken from the best practice policy. It's not going to let me do that, is it? That's really quite annoying. Anyway, so you can see you've got custom URL categories at the top, which will be evaluated first, the site access and the user credential submission. So if you have this, if you're integrated into AD and it's aware of AD and it can poll the AD, and as well, crucially, that it's decrypting the traffic, it will pick up, the firewall will pick up any user credentials that are sent across to any of these particular categories. So then going down, we've got all our standard stuff, hacking, health and medicine, high risk, and so on. And then we have the action, so the site action, the site access, that's going to be part of that. So you've got alert, allow, block, continue, and override. So you can continue or you can override it. Two very different things. So continue is basically the user has the opportunity to continue. Do you want to continue onto this? And that's more it's more an end user education piece, really. As a user goes to a website that is against company policy, they will not necessarily against company policy, because you probably want that on override, but a URL that is frowned upon, shall we say, frowned upon within company policy, they get given the opportunity to continue, and you can then customize that response page for whatever you want. So make them aware of the fact that their access will be logged, and the username will be logged, and so on. So giving them the opportunity to go to it. Override is completely blocked, but with the opportunity to override that block given a username and password. That again can be customized right down to the amount of time that you want to give the override for, and again that'll be logged and so on. So the user credential submission is, as I said before, you can alert, allow, block, and continue. Can't override it; it's pointless. So you would alert to say, yep, somebody's putting their corporate credentials into it. Allow, I guess, if you didn't care in this particular instance. Block it completely, or continue, as in then give that person a warning. Okay, so one of the ways of controlling these things, and in here, of course, we've got what we had before, which is the log container page only, safe search enforcement, and then the HTTP header login. So this just includes in the logs the user agent, the referrer, and X-forwarded for. So if you've got any proxies or anything like that, you'd have the x-forwarded for header in there as well. User credential detection, as we said before, is disabled. Header insertion, so you can insert into the request. You can insert a header as well. So this one, for particular instance, is the YouTube Safe Search header. That's it, YouTube restrict. So that's the header value that we put in, and for those domains. And then when you make requests out to YouTube, it will to these, which are YouTube, it will add that header. And then the inline machine learning. Now, the inline machine learning is it's part of the extended DNS, or the advanced DNS, I believe they call it. So it does basically what it says on the tin. So it gives you the opportunity to, the first vendor to use inline machine learning. And on here you've got just 3, which is alert, allow, and block. And save for that one. And that just says what it says there. So it's to dynamically identify credential phishing pages. So looking at the way the page acts, looking at links on it, and anything that looks potentially suspicious, using machine learning, that will really cut down on your initial contact with it. When nobody else has had contact with it, you're going to it for the first time, which does happen. This is in place then to stop you getting caught out by 0-day phishing pages and so on before a signature can be created and passed on. And the same for JavaScript-based exploitation attacks. So what if we then wanted to create our own categories for whatever reason? Because the problem with these is, these are pretty overarching. Health and medicine, there's a lot of websites in that. So if we wanted then to create our own categories, we can create the custom categories here. And to create a custom category is really quite easy. Give it a name, type, so category match or URL list, so you can match on a particular category. And then the sites under there. So that's where you have your sites for your searches and stuff. That's what these sites are. So in this particular instance, if I wanted to not decrypt, then you can see that I can not decrypt twitter.com, subdomains of twitter.com, Palo Alto Networks.com, subdomains of, and then Palo Alto Networks.com. And there are operators front and rear that you can do. In fact, actually, for the sake of that, we'll just go through that now and just explain those. Okay, so if we add one, and we're going to call this our donkey we would do donkey list, and this is going to be our test URL list for donkey.com. So if we then add, so for instance, if we had donkey.com, that would match excuse me, that would match donkey.com. That's it. So you would then be caught out by referrer sites and so on. If we were to change that to star.donkey.com, then that would cover any levels, so basically 2 or 3 levels of subdomain. So if you had engineering.tools.donkey.com, that would cover that. Then we also have the caret function as well. So we can go, caret dot. So that's going to be a single level of domain because caret is from the start. So we've got a single level of domain. So for instance, this would match engineering tools.donkey.com, but not tools.engineering.donkey.com. We can double that up in order to then have the engineeringtools.donkey.com back. If we're then looking at sort of URLs on the other side of that, you can allow all URLs. You need a dot there. You can allow all URLs, and again the carrots work the same way. So 1 level, 2 levels. Then moving further down, we can then put those, and those then work in the middle. So it's, anything like if you have site a.donkey.com and site b.donkey.com, you would have site dot, and that would match. It'd have to match site, whatever your value was, and then donkey.com. Okay, so we'll leave the donkeys alone for a minute. We'll move away from there. So then that's then your URL list, and you can then decide what to do within that URL list. So if we go back to URL filtering, and we go back to our home policy, we can see that what we've got in there then is the same options and the same thing, but just following our different custom URL categories. And this comes in very useful for a lot of reasons. You can create custom URL categories and custom IP lists to whitelist and blacklist, or allow list and deny list as it is now. Different things as you go through. Keep forgetting to do that. Hang on. All right. So once we've created our URL categories, we can go into our, not that one, anti-spyware. Go into home anti-spyware. So in here is where this is where we configure all the signatures and signature exceptions, and we have DNS policies as well. So within the DNS policies, this is where we configure all our sinkholing and the actions based on the varying categories of DNS security that Palo Alto have put out there. So in here we've got the opportunity. So log severity, we can change the log severity based on what we think it is. So command and control domains is default. So whatever the default is, which in this case is high, will then be used. Now, if you were like me, for instance, I spend a lot of time looking at malware sites and looking at greyware, things like that, from the offensive security side of things. You probably wouldn't want a high alert being fired off every single time. So you can then change that. So you could make that informational. Okay, and then you can sinkhole it. So it's default, which is allow or block based on the default action as determined by Palo Alto. You can allow it, so it's overriding the default action if the default action is to block, or block if the default action is to allow, or sinkhole. And sinkhole, of course, is, as we said before, I keep doing that, it's really annoying. Sinkhole is, of course, what we said before, which is the way you can sinkhole the DNS. So you know for a fact that they're not getting a DNS reply from it, and then you can then go and look and see what hosts are going to the sinkhole address. So packet capture is as it is before. So should this then get fired, you can either disable the packet capture not to capture anything, capture a single packet to capture the header information, the initial SYN, or the extended capture to capture more of the traffic as it goes through. But on sinkhole, I don't know if that's necessarily a good idea, even though I've got it set down there. And then the default Palo Alto DNS is the same thing. Basically, it's the machine learning side of things. and you got the sinkhole and extended capture options there as well. So for DNS exceptions, so this is where you want to put in your DNS exceptions so that they don't fire the alerts, or so they then get ignored and they're allowed. So this basically the DNS main FQDN allow list, as it says. DNS signature exceptions are as it says for the signatures, and this of course is where we get the anti-spyware signatures as well, where we can see all the threats that can come through. Got threat ID, policy, critical risk, category, severity, and then the action, which is reset both. And in here, so you can have the alert, which is the just alerts and saves it in the log. It then carries out the default action. So if the default action for that particular connection, as in this case, is reset both, so it would alert and then reset both. You can allow it. You can block the IP. So if you block the IP, that actually blocks the IP from either from the source or a source destination pair. So you can configure it as it says IP source or IP source and destination. So if you're blocking it, anything's calling out to it, just an IP source, and that would block that for the amount of time that you put there. And then IP source and destination, it would track it that way and it would make sure it was blocked that way. Hang on, that was not ideal. Okay, drop it, which is silently drop. So when you drop traffic, you don't send back any kind of notification that traffic's been dropped. Reset both, which is reset packet to client, reset packet to server, and then just reset client or reset server, and then the server just be left open or the client just be left open with no notification either side. As you can see in this particular instance, because I had a lot of trouble with these two, which were nothing really, the default was allow, and they were just clogging up the logs. It just seemed better to just avoid them. And that's that. So if you are caught in a situation where you have configured URL filtering and anti-spyware and so on, those are really the places that you're going to have to go to remove it. So go to URL filtering, and you look at the policy that it's there. You'll have the policy that's being blocked on, and then you look at take server test, for instance. You can check the URL category there. So if we want to, let's say we want to go to that, I'm not a robot. Wow. And search. So we can see that my website is low risk, and go for that. Computer and internet info, and then the description of it there. Different sites. I'm up there with Alexa and so on, which is all good. And then you can request a change for that if you want. So if you find something that is being flagged as malicious, for instance, if we were to go to this one, which kept being flagged as malicious, you could then request a change. Now, I didn't, but I felt it was wrong because scaregrounds.co.uk was just a website for Halloween attraction. However, this could also be taken from the fact that wherever they've hosted it has also got websites hosted at the same address or wherever where malicious activity has come from. So it could be being blocked on that. So there you go. So now just a quick word about the ACC with regard to looking for for any kind of rogue activity. So if we go to DNS security and just let it clear that filter. Okay, also always bear in mind it's a PA220 this. I know it's up there in the corner, but it's easy to forget. And it becomes less easy to forget when you're waiting for it to do something. So, what we've got, so DNS security, we can see that we've got low risk, medium risk, and insufficient content. Let's not bother about that. We don't need to bother about that. So, within the, say, medium risk, if we wanted to see who is going to that, we pop it onto the global. Okay, now we still haven't got any count here, and this is because we have DNS proxy. So this is what I'm assuming it's because. I think it's because of that. But what we can do is, because we've got a global filter there, we can go to network activity, and this will filter now on global, and that global filter is there, and it will show us in the last hour who's been going to it. And so literally ACC is your friend. And I mean, additionally as well, you've got to bear in mind that on Panorama it's exactly the same. And that's why Panorama is such a fantastic platform, is because it's exactly the same as using ACC and so on. Here, so we know it's SSL application. It says there is no source user because this particular 25 is a server. But we know that 25 is going to it, and we know that that's where it's going to, which we've already got. Destination address is there. Source country, a little bit pointless at the minute because it's just here. Destination country, it's in the UK, and it's medium risk, and the rule that it was on. And if we add any HIP information, so host information, if we had any of that, it would be in there as to what that was. So what you could do then is you could pop that in global, get rid of that. Okay. And then we can come back and we can see. So we've already seen that. We've seen that that's going somewhere dodgy. All right. So let's have a look and see where else it's going. We can see where else it's off to. So we can see now the application traffic that's coming off it. We can see it's hitting some medium risk stuff and what the medium risk stuff is. Again, it's going United Kingdom, and then we've got some insufficient content. Now, the insufficient content in this particular instance will be TikTok, I would have thought. See if we've got any applications, any apps. So then we can see, so in the apps, we've got media, 2 sanctioned ones, networking, 3 unsanctioned, general internet, some SaaS, none known. Click into SaaS, we can see we've got internet utility and social networking. Click into social networking, we've got Facebook base. So you can see I can really drill right down into exactly what the traffic is and where it's coming from. And then based on that, then you can look and say, well, okay, well, is this a risk or is this not? And of course, all this can be done as well through XOR. So in my last video for DNS security, I did actually allude to the fact that we should do this through XOR. And I think what we should do is actually, I need to sit down and do the video of how we can actually get XOR to do all that for us, drag all the information back, present it to us, and then based on the risk, we need to look at how we can either block it immediately, pending us looking at it, or just alert us and then get us look at it and block it as a result of investigation. So that's DNS security. That's DNS security 2. The first one, so was a really good video. So yeah, so let's try and get the XOR one done.